In this tutorial, I'd like to talk to you a little bit about DeMorgan's rule. So in DeMorgan's rule, you can have really complex things that look like this. This is a valid expression. For that to work, I do need to declare the variables, and usually I declare my variables at the top, but since I'm starting a new idea here, let me go ahead and declare them here. I'll say int x, comma, y, comma, z, comma, b, comma, c. I think I've declared all the variables. Now it's still very angry at me, partly because the variables haven't been assigned values. Let's say that x is equal to 2. Let's say y is equal to, say, 3. I'll say z is equal to 4. And I'll say b is equal to 1 and c is equal to 2. Actually, I'm repeating some variables. Let's say minus 2. Now, if you want to see what the punchline is on this, it's easy enough to evaluate. System.out.println. In a flash, you can always figure out what that's equal to. Put parentheses around the whole quantity for the system out print line. Also put parentheses around the entire expression. If it's mathematics, you have to have that. Now it looks like Eclipse put in an extra parenthesis there for me, and it still looks like I have an issue with a semicolon here, but you can see that works. Do you all understand? This here, from here to here, is just for the system out command. That's what the outermost braces were. The next braces are just to say I have a quantity I want to evaluate. Give me a single answer for what it is. It is not this. DeMorgan's rule involves figuring out how do you carry an is not across an entire quantity like this, and that's what I'm about to show you. Okay. Let's go ahead and evaluate it. I'll show you how you evaluate it to determine what your answer is. If in DeMorgan's rule you use a rule like this, I would say the easiest way to evaluate it is, first step, just recopy what you've got here and substitute your values. What's an x? If you're predicting what this is going to be, which you will have to do for a quiz or a test in the future, substitute your values. 2, what's y? 3, what's z? Looks like, I declared it, but I never assigned a value. Let's say z is equal to, oh yeah, I did. Okay, so z is 4. Missed it. B is what? 1. C is -2. That's really what we're evaluating. So once you jump to this step, that's a big part out of the way. Let's go ahead now and evaluate everything that I've got here. So my next step, if I'm going to evaluate this, you have to know that according to DeMorgan's rule, you take the is not through here and you reverse everything that's in there. You say, what is this not? And you switch it. So I'm going to apply, just as though I'm multiplying this is not across everything in the entire quantity. Can you tell me what is not less than? What is not less than? It would be a is greater than or equal to. Do you buy that? What is not an and? It is an or. What is not an is greater than or equal to? What is not an or? What is not a not equal to? What is not an and? What is not an equals equals? So you should see how I made those. Now what you need to do is you just need to look at that quantity and evaluate what you get as you simplify it. And you need to know what the order of operations are when you do this. So from C++, you should know that the rules go like this. What gets evaluated first, guys? Parentheses. Then what? Your ands. Then what? Your ors, in that order. So it's just like order of operations in mathematics. Let's go through here and see what we've got. Have I got any parentheses? Thank heavens, no, I don't have to deal with it. So what gets next attention? The ands. So I have an and right here. What is it telling me? It means that I've got to evaluate what this condition is from here to here. Now, a sub-step you can do here that I find kind of helpful is if you just go in here and right now evaluate these things as true or false, and then we'll find out what the meanings of the ors are. Is 3 greater than or equal to 2? Yes. So underneath that, let's just write a little t there for true. I then have an or. Is 3 less than 2? That's a false, so I'll write a little f there. I'll bring down the and here. Is 4 equal to 2? That's a false. The or just comes down. Is a 1 not equal to a minus 2? That's true, so I'll write a little t there. Most of you have had this from my C++ courses, so you should know this. So now once I get to here, I should be able to do the ands now pretty easily. The and is the first thing I'm going to evaluate. What is an f and an f? That is an f for sure. I'm going to line that up right under the and so I know I evaluated that. If you take the time to break this into steps, you're going to make it much easier to do. What's the next thing that happens? Well, it looks like I have 2 ors, and they're both tied. So in a tie, we know from mathematics, what do you do next? Left to right. So I'll go ahead and evaluate this. I hope this all comes out how I want it to. Every once in a while I get surprised. Anybody see any issue with what I've got so far? Okay, so if I read left to right, what is a true or a false? That would be a true. So this or here is evaluated as true, but I have yet to evaluate the next or. And now obviously if I evaluate a true or a true, what are you going to get in the next step? Should be, I am predicting that when I evaluate this, it will be a true. But understand this, I will give you a problem just like this, and I will ask you, use DeMorgan's rule to evaluate whether this is true or false. You better be right. You won't have a computer to figure it out. Let's see what it says the punchline is. It tells me it's true. That was exactly what I predicted. Everybody feel comfortable with that? Are we all right? This concludes the tutorial over DeMorgan's rule.